Good morning, dear students. How you all are doing? Are you all fine? Yes? Okay. So this is the second slot, that is from 11 to 12. Okay. I hope that you have enjoyed your first session. It was with Puneet Katuria sir. This is the second slot, and what we are doing, we are discussing this paper AIATS plus 2025 phase 2, and the paper name was mock test 7, and it was conducted on 2nd of March 2025, right? We are here to discuss physics part. Okay, so in this 1 hour session I am going to discuss these chapters: laws of motion, work, energy and power, gravitation, mechanical properties of solids. These are from 11th class, your 11th class, right? And atoms and nuclei, these are from your 12th class. All right. So without wasting any time, let's see the first question. That is, if radius of innermost electron orbit of hydrogen atom is 0.53 angstrom, then radius of n equal to 3 orbit is. Okay. So radius of innermost electron is given as this 0.53 angstrom. Now we have to find the radius of n equal to 3 orbit. So we know the formula, right? We know the formula of radius of orbits. What is that formula? So r is equal to, that is radius is equal to r naught into n square by z. Now what is n and what is z? So n is your orbit number, right? Orbit number. So n could be 1, 2, 3 like this, right? What is z? Z is atomic number. Atomic number. So this is atomic number. What is r naught? This is constant actually. Okay. So I can also write this as 0.529 angstrom into n square by z. Okay. So the unit of r naught is a angstrom. And what is angstrom? Angstrom is 1 angstrom is equal to 10 raised to power minus 10 meters. All right. So this is your formula, that is r is equal to 0.529 angstrom into n square by z. Now can we find the answer of this question? Obviously, right? So 0.53. Okay. So as you can see that I have written 0.529 angstrom. This can also be written as 0.53 angstrom. Almost equal, right? Now radius of n equal to 3 orbit. Just put n is equal to 3, alright. What will be the value of z here? So we are dealing with hydrogen atom, right? So if we are dealing with hydrogen atom, then z is equal to 1 for hydrogen atom. For hydrogen atom. Okay. Similarly, if we are dealing with helium, then we have to write z is equal to 2. That's it. So you have to write the correct numbers in this parameters. Okay. So this will become r is equal to 0.529. I am writing it as 0.53 into n is 3. So this will become 3 square divided by 1. So this is 0.53 into 9. What will be the value of this? 9 into 3, 27. So this is 2, 45, 47. So this is 477 and the decimal will come here. So 4.77 and the unit, you know, it is equal to angstrom, right? Okay. So this is our answer, 4.77 angstrom. So we know the formula of radius now. Now what else? What else we can do in this question? So you know the electrons in orbits move with some velocity or some speed, right? And what is the formula of that? So V is equal to V naught, that is equal to 2.18 into 10 raised to power 6. Again, unit is very important, okay? So this is 2.18 into 10 raised to power 6 meter per second into Z by N. Okay, Z is again the same atomic number and N is the orbit number. 2.18 into 10 raised to power 6 meter per second. As you can see, this speed is huge, right? This speed is quite huge. 2.18 into 10 raised to power 6 meter per second, Z by N. What about the energy? So E is equal to minus 13.6. Again, unit is important, that is electron volt, not in joule, okay? This is in electron volt into Z square divided by N square. Okay? Z square divided by N square. So these are the formula which you have to remember Okay, so R is equal to, I will again write here, R is equal to 0.529 and unit is angstrom into n square by z. V is 2.18 into 10 raised to power 6 meter per second into z by n, and E is equal to minus 13.6. Unit is electron volt into z square by. Okay, Aakash to AIMS. Sir, last question फिर explain कर दीजिए. This is the only question we have discussed so far, Aakash. Okay, so if radius of innermost electron orbit of hydrogen atom is this, then radius of n equal to 3 orbit is we have to find, right? So we have applied this formula, that is R is equal to 0.529 into n square by z. Then we put the values of this n and z here. So as you can see, I have written 0.529 as almost equal to 0.53, and the value of n will be 3, which is already given in question, and z is equal to 1 for hydrogen atom. Okay, solving this, we got this answer. Is it okay now? Aakash to AIMS, is it clear to you now? Okay, let's move to another question then. So this is the second question, that is, in the given reaction, the element X is, what is the reaction? This is C612 plus 0 and 1 X. You have to find the value of X, right? Or the element of X, and this is minus 1 beta 0. Okay, so have you see this? Have you seen this kind of reaction? This is a nuclear reaction, right? And what is this minus 1 beta 0? So the numbers here, the numbers here shows that these are the atomic numbers or the number of protons, right? And this is mass number. As you can see here, this is mass number, this is mass number. We have to find the value of this, so it is not given here, and this is mass number. Okay, so for beta, the mass number is 0 and number of proton or the charge on it is minus 1, like this. Okay, so before solving this question, let's see. This is related with radioactivity, right? So there are 3 types of radioactive reactions which we study, that is beta minus, beta plus and alpha. These are the 3 kind of emissions we see or we study. Okay, so what is beta minus, what is beta plus, and what is alpha? Alpha is very easy. Okay, you know that alpha is nothing but helium nucleus, right? So what is the atomic number for helium? That is 2. And what is the mass number of it? That is 4, right? So alpha is nothing but this. Okay, so if some nucleus is emitting alpha particle, then we can say that it has emitted this. What it means, that its atomic number will be reduced by 2 and its atomic or its mass number will be reduced by 4. For example, let's take a reaction. Let's say this is X, this is Z, this is A. Okay, some nucleus which has atomic number as Z and and mass number as A. Okay, now if it releases alpha particle, one alpha particle, then what it will become? Let's say it will become another nucleus. Okay, it will become another nucleus as Y. So this is Y. What happens to its atomic mass? It will be reduced by 2, so it will become Z minus 2. What will happen to its mass number? It will be reduced by 4, so this will become A minus 4. Alright, are you getting this? So this is alpha emission. What about the beta minus and beta plus emission? What is beta minus emission? Okay, this is beta minus emission. Now this beta minus is nothing but electron with minus charge and 0 mass number. Okay, so beta minus is what? Minus 1, that is its charge, and at mass number is what? 0. So let's see how it looks like in a reaction. So what really happens is that there is a nucleus, okay, and if it emits beta minus, okay, so if it is emitting beta minus or an electron, what happens is its neutron would convert into a proton and a electron or an electron is released from it. Okay, so the reaction would look like this. N, okay, this is 0, this is 1. Why? Because there is no charge there is no charge on neutron, right? It has mass 1. This will be converted into a proton and its mass will be 1 and its atomic number is also 1. Plus, there will be a release of electron that will be -1 and 0. And as you can see, the numbers in the subscript and this superscript should remain same, right? So, 0, this is 0, right? So, this is 1 minus 1. This will become 0 again and this is 1. So, this is 1, this is 0. 1 plus 0 is 1 again. Okay. So, this is beta emission, beta minus emission. This looks like this. Any doubt so far? This is beta minus emission. Now, can you tell me what happens in beta plus emission? What happens in beta plus emission? Anybody? So, in beta minus emission, neutron inside a nucleus converts into a proton and an electron is released. What happens in beta plus emission? A proton inside a nucleus, and how will we write proton as 1 P1, right? Atomic number is 1, mass number is also 1. It will converted into a neutron that is equal to 0, 1, okay? Atomic number is 0 and this is 1, plus a positron is released here, okay? So, it is also shown by this and this will become 1 and this is 0, okay? This is positron actually. So, positron is an anti-particle of electron, okay? It is exactly opposite to electron, okay? So, its mass is exactly same as electron, but its charge is opposite of electron. So, that's why you see a positron looks like this, that it has a positive charge of 1, but its mass number is again 0. This is beta plus emission. Although it's rare, but it occurs in the nature, okay? Usually what you say that beta emission means by default, if nothing is there, so by default, beta emission means beta minus emission, okay? By default, beta emission means beta minus emission. Is it okay? Now, can you solve this? Okay, we have seen alpha emission, beta plus emission and beta minus emission. So, can you give me the answer of this question now? So, this is 6C12 plus N01, right? Which will give me this is 1, this is x and this is -1 beta 0, okay? You just have to balance this numbers on this x here, okay? So, this is 6 plus 0, that is 6, this is -1, so this will become 7, 7 minus 1 will become 6, right? Now, this is 12 plus 1, 13, here it is 0, so this will become 13, okay? So, just how you do it in chemical reactions, right? You just have to like balance the numbers here. So, this is 6 plus 0, that is 6, 7 minus 1 will become 6. This is 12 plus 1, 13. This is 13 plus 0 is again 13. Now, you can remember what is the atomic number 7. Atomic number 7 signify for which element? Its atomic number is 7. Carbon has atomic number 6, it is already given here, okay? So, you can easily eliminate that carbon could be the answer. No, it can't, right? Because the atomic number of carbon is 6. What about the nitrogen? It looks like this is the answer, right? Atomic number of nitrogen is 7. So, this is the answer. Oxygen, what is the atomic mass of oxygen? That is 8. And helium, for helium, the atomic number is 2. Right? So, the atomic number of helium is 2, oxygen is 8, nitrogen is 7 and carbon is 6. Our answer is nitrogen. Any doubt so far? Any doubt so far? No? Okay. Yeah, Abhishek, nitrogen is the answer. Okay, let's move to another question then. Read this question. the question says a block of mass 5 kg is moving along x-axis under the action of a variable force F is equal to 10x Newton. Is this force variable? Yes, this force is variable. Why? Because it is changing with coordinates, right? So this force must be variable. It's not a constant force. The work done by the force in moving the block from x is equal to 4 meter to x is equal to 6 meter will be. Very easy question, right? But the force is variable here and we have to integrate the work done by this force. So what is the fundamental formula to find the work done? So work done is equal to integral of F vector, force is a vector, right? F dot dr, right? Dot product of two vectors will be a scalar quantity. So work done is a scalar quantity, F dot dr. Now, how can I write this dr vector in coordinate system? So in terms of coordinates, dr vector can be written as dx I cap plus dy j cap plus dz k cap, right? So dr vector can be written as this, but here as you can see, the work done or the force is given as 10x and the displacement is also happening in x direction only. So I can also write this work as F dot dx already, right? So F into dx, this could be our formula for this question only. Okay, so I am solving it now. So this is work done is equal to F dot dx or F dx. What is the value of force? That is 10x dx, right? Now we can take out 10 from the integration because it is a constant number. So this will become x dx, right? And the limits of x will be from 4 to 6. So this is 10 into integration of x will become x square by 2 and the limits will be from 4 to 6. Just simplify it, this will become 10 by 2, that is 5. X square is, first you have to put the upper limit, that is 6 square minus, right? Upper limit minus lower limit, right? So now you will put 4 in place of x and this will become 4 square. So this will become 5 into 6 square means 36 minus 4 square means 16. 36 minus 16 will be equal to 20. 20 into 5, the answer would be 100 joule, right? Answer would be equal to 100 joule. So this is the answer. Option number 4 contains our answer. That is work done is equal to 100 joule by this. Abhishek, why you are saying telling me the answer is 60? The answer should be 100 joule, right? We have already like calculated it. Have I done something wrong here? Abhishek? No? So the answer is 100 joule. Okay, so work done by a variable force can be calculated like this. Okay. Now tell me, if there is another question, let's say that force is a variable force is given, okay, and that is equal to 2x I cap plus let's say 3y j cap. Okay, we are taking this force in 2 dimension only, 2x I cap plus 3y j cap, and both the elements are, Abhishek, okay Abhishek, both the elements or both the components are variable. It is variable in x direction as well as in y direction. Now let's say I am displacing this particle from 1 I cap plus 2 j cap to R2, that is equal to let's say 3i plus 3 j cap. Okay, now can you tell me the answer? How can we solve it? Fundamentally the formula remains same, right? So integral of f dot dr. Now you will need the formula this form, f dot dr, and f can be written as 2x I cap plus 3y j cap dot, okay, dot product. So this is dot, dr can be written as dx I cap plus dy j cap. Okay, since there is no force in the z direction, that's why I am not taking the element in the z direction and I am also not taking the displacement in z direction. Okay, so this is the formula. Now 2x I cap plus 3y j cap dot product of dx I cap plus dy j cap. Now we know how to do the dot product of these kind of vectors. This will become 2x dx and this will become 3y dy. Okay, because the dot product of I dot j will become 0. Similarly, the dot product of j dot I will become 0. So we get the final expression like this. This is integral. We haven't done the integration. Okay, already we have only solved this dot product now till here. So 2x dx, okay, and plus again integration can be written like this, 3y dy. Can you solve this now? So this will become 2x dx, work done. So 2 will come out, integration of x will be x square by 2. I will put the limit 2, right? So the limit of x is 1 to 3, right? So this is from 1 to 3 plus 3y. So the integration will become 3, will come out. This is y square by 2 and the limit would be from 2 to 3. So this is the limit from 2 to 3. 2 and 2 will get cancelled. 3 square means 9 minus 1 square means minus 1. This is the work done in x direction plus 3 by 2 and put value of 3 here in place of y. So this will become 3 square means 9 minus 2 square means 4. So solving this we will get 8 plus 3 by 2 into 9 minus 4, that is 5. 16 plus 15 by 2, that is equal to 31 by 2 joule. This is the work done by this formula. Which force? This force F equal to 2x I cap plus 3y j cap, and displacing the body from this position vector, initial position vector, to final position vector. Okay, study 7 joule or 7 j cap. What is this comment regarding what? There is nothing like 7. Okay, so this is the answer. I hope that everything is clear so far. So we know now that how to deal with variable force in 1 dimension as well as in 2 dimension. Okay, similarly you can extrapolate this formula for 3 dimensions too. The work will remain exactly same, or the this method will remain exactly same. Okay, let's see the another question then. In hydrogen atom, energy of first excited state is minus 3.4 electron volt. Then the potential energy of same orbit of hydrogen atom is excited state. Okay, so this is the excited state, and energy means total energy here. Okay, so total energy is minus 3.4. Fahad, ये चल क्या रहा है? Okay, so we are discussing problem of physics. Okay, so there was a paper or a program which was going. So it was AIATS plus phase 2. Seventh paper was there which had been conducted already. Okay, so we are discussing the problems of that question. Okay, Fahad, I have already told you. Okay, then the potential energy of same orbit of hydrogen atom is. So we have to find the potential energy. So total energy is given and potential energy you have to find. What is the relation? So if you know that total energy is equal to potential energy by 2, the sign will remain exactly same. That should be equal to minus of kinetic energy. Okay, so as you can see, I can write total energy and kinetic energy are equal in magnitude but opposite in sign, and I can also write it like this, that total energy is equal to potential energy by 2. So the sign will remain same, but the magnitude of potential energy will be twice of total energy, or total energy is equal to half of potential energy. Okay, study, you are giving me answer 3.4. Let's see. Okay, so total energy and potential energy. So we have already given with total energy and we have to find the potential energy. Okay, just put the values in this equation. Okay, so potential energy is equal to twice of total energy, and that would be equal to 2 into minus 3.4, that is equal to minus 6.8 electron volt. Okay, so this is the answer. Study. Okay, So this is minus 6.8 electron volt. Abhishek saying, you have given me the answer A. No, answer A is not correct. Okay, are you getting this now? The answer should be minus 6.8. No, not plus 6.8. It should be minus 6.8. Na? See, the total energy is minus. It is in negative, right? And the magnitude of potential energy is twice of total energy. It is exactly like just multiply 2 with whatever total energy you are given with. So, minus 3.4 into 2 will be minus 6.8. Okay? Kinetic energy will be positive. Here, total energy and potential energy will be negative. So, as you can see that total energy, the formula of total energy is minus 13.6 into Z square by N square, है ना, in electron volt. This is for hydrogen atom. This is for hydrogen atom. है ना? तो for hydrogen atom actually we have to write Z is equal to 1. This is applicable for all type of single electronic species. Okay. So for Z is equal to 1 and N equal to 1, we will get minus 13.6 electron volt. For Z is equal to 1 and N is equal to 1. It means for the first orbit of hydrogen atom, the total energy is minus 13.6 electron volt. Okay. Now, what happens with potential energy? Potential energy is twice of total energy. So this is equal to minus 13.6 into 2. What will be the answer? 1326. So this will become 27.2 electron volt with negative sign. So potential energy is minus 27.2 electron volt. What will happen to kinetic energy? Kinetic energy is minus of total energy. So this will be minus of 13.6 electron volt. So this will give us plus 13.6 electron volt. Kinetic energy is half mv square, right? So it cannot be negative. It has to be positive always. Yes, Sukanya. So potential energy is this, kinetic energy is this. Now I can also write total energy as kinetic energy plus potential energy. Total energy is the sum of kinetic energy and potential energy, right? So kinetic energy is 13.6 electron volt plus, what is the value of potential energy here? So this is minus 27.2. The summation of this will again give you the value that is equal to 13.6 electron volt in negative. Are you getting this now? So total energy would be again same as minus 13.6 electron volt. Potential energy will become twice of that and kinetic energy will be minus of total energy. Is it clear now? Study, Fahad, Sukanya, is it clear now? Right? So the answer is minus 6.8 electron volt. The students who has given me the answer as 3.4 or 6.8, I think it is clear for you now. Okay. Right? Okay. So let's see another question then. This is the another question, that is elastic potential energy per unit volume in a stretched wire is equal to. Now these are the options. Okay. See this last option, that is it contains both 1 and 3. Okay. So in these type of problems where there are multiple options and another one option is there which says that both 1 and 3 or both 1 and 2, you have to solve these kind of problems very like attentively. Okay. Because it could be possible that you get the answer as 1. Okay. You take it and you go to another question, but it is possible that its another option is also correct and hence the option 4 could be correct here. I am not suggesting you that fourth option is the correct option. Okay. That we have to see, we will solve it and then we will get whether the fourth option is correct or not, but you have to solve this question like this. Okay. So always remember that when a question says that multiple options could be correct, so you have to solve all these options. Alright. Okay. So you are already giving me that option 4 is correct. So Kanya, study and Lakshman. Yes, you are right actually. Okay. Both the options are correct, but we will see how. So elastic potential energy, and that is per unit volume. So elastic potential energy per unit volume, elastic potential energy per unit volume, and it is denoted by small u. Okay, it is denoted by small u. So small u is equal to half strain, or let's say stress into strain. Okay, in terms of, like, stress is denoted by sigma and strain is denoted by epsilon. So this is the formula we have, u equal to half sigma into epsilon. But there are other formula, है ना, where sigma, epsilon and Young's modulus are related, which is sigma is equal to gamma epsilon. So you know what is sigma? Sigma is a stress. You know what is strain? That is epsilon. And this gamma or y is Young's modulus. This is Young's modulus. Okay. So we have one more formula here, right? So what I can do is u is equal to half sigma into epsilon. This is one form of this formula. I can eliminate this sigma with the help of this formula. So I can write sigma is equal to gamma into epsilon. So this will become half sigma is gamma epsilon, है ना? And gamma is already here. So it will become half gamma epsilon square. That is half Young's modulus into strain ka square. This is another form of this formula. So elastic potential energy per unit volume can be written like this, u is equal to half sigma epsilon, or you can also written like this, u is equal to half gamma or Young's modulus into strain ka square. Okay. What else we can do in this formula? We can also eliminate this epsilon here, right? And we can write this formula in terms of stress then. So it will become u is equal to half sigma epsilon, and in place of epsilon, I can write epsilon is equal to sigma by gamma, right? So this will become u is equal to half sigma. In place of epsilon, I am writing this sigma by epsilon gamma. So this will become sigma square by 2 gamma. That is stress ka square divided by twice of Young's modulus. So we know the formula of energy per unit volume in terms of sigma epsilon, in terms of gamma epsilon, and in terms of sigma gamma. Okay, so what should be the answer now? You already knew the answer, है ना? Half stress into strain, this is correct. Half stress into strain into volume. No, this is not correct actually. I will tell you how and why. Half Young's modulus into strain square. This is again correct, right? So both 1 and 3 are correct. That's why this is the correct option. Okay, this is the correct option. Both 1 and 3 are correct. Is it okay so far? Okay, now why this answer is not correct? Actually this is also a familiar term. Can you tell me, can someone tell me what is this? Half stress into strain into volume. This option is here to confuse you, because you know this is also a correct formula of something else. This is not the formula of elastic potential energy per unit volume, but this is also a correct formula for something else. What something else is? Anybody? Okay, so U is equal to energy per unit volume, right? So this can be written as U, total energy per unit volume. Okay, I am writing this as volume. So total energy can be written as U into volume, right? So U is equal to, what is a small u? That is half sigma epsilon. And what about volume? That can be written as or it is also already written here in terms of volume, so I am writing it here as volume. So U is equal to half sigma epsilon into volume. Half sigma epsilon into volume. This is actually elastic potential energy. Not per unit volume, this is total elastic potential energy. The steady empire, beta, energy density is actually small u, okay? This is energy, this is volume na, so energy per unit volume, this is energy density. Yes, study. Very nice. Elastic potential energy. Manvendra, are you getting this now? Okay, so this is already energy density. Now you multiply that energy density with volume and you will get the total energy. Got it? Okay. Any doubt in this? No? Let's see another question then. This is another question. A force is delivering constant power of 20 watt to a body. If the force is acting in the direction of the motion, then the magnitude of force when velocity is 10 meter per second. Very easy question. Very easy, right? We are given with the force. No, we have to find the force. We are given with the constant power of 20 watt. We are given with the velocity at some point of time. Now we have to find the formula of force or the magnitude of force by this. Okay, what is the formula? So P, power. Okay, so power is work done per unit time. And we also know that whenever we do work done or work on something, then it will transform into energy, right? So energy consumed, dissipated, or energy given to some body divided by time. This is power. Okay. So what is average power? Average power is like something or some machine is delivering energy, okay, or doing some work. So we see that, okay, I have to find the average power in 1 hour. So we will calculate that what is the total work done by that machine in 1 hour. Okay, so that will be the total power. But in some cases we need instantaneous power. Okay, yeah, all of you are giving me the correct answer. Study. Saina Sultana, Lakshman Patil, very nice. Okay, but now concentrate on this. So we know how to calculate the average power. We can also find the what? Instantaneous power. So what is the instantaneous power then? So as we know that P is equal to dW by dt. Right? We have to find the instantaneous power. So instantaneous power will be equal to, this is instantaneous power, and that will be equal to dW by dt. Now what is the formula of W? W is F dot ds, displacement. Okay, F dot displacement. So power can be written as d by dt. What is d by dt? This is the differentiation, right? And I am writing it as F dot ds. Now for a very small point of time, okay, almost that time is tending to 0. For that time we can assume that that force remains constant. It could be variable in a long time, but for a very small time it will remain constant, right? So when I differentiate this d by dt, so this will become F, this force is remaining constant for that small time, so this will become F dot ds by dt. Okay, see, I have written here this d by mistake. Okay, so d by dt, differentiation of this force into displacement. So this is small displacement here. Okay, so for a very small time the displacement would be very small, so this will become F dot ds by dt. So this is F dot ds by dt, and what is ds by dt? That is equal to velocity, right? So this is F dot v. This is power. So instantaneous power we know now, that is equal to F dot v, right? Now can we apply that formula here? Yes, we can apply that formula. So P is equal to F vector dot v vector. Okay, F vector dot v vector. So here, as you can see, force is a vector, velocity is a vector, and dot product of these two vectors will be a scalar quantity that is equal to powers. That is why power is a scalar quantity. Yeah, Saina Sultana, if force is not constant, so at that point of time, whatever be the forces and whatever be the velocity, that dot product will be equal to instantaneous power. So let's say a force is a variable. Let's say it is equal to 2t square. Okay, Newton force, and I am taking this in x direction, so that is why I can drop this F vector here. Okay, Saina. Others also focus here. So if the force is variable, so let's say F is equal to 2t square Newton. Okay, so it is dependent on time, hence it is a variable force. Now, at some point of time, let's say the velocity becomes 5 meter per second. Okay. At some point of time, or let's say at t is equal to 2 seconds, at t is equal to 2 seconds, the velocity will become 5 meter per second. So what happens here? T is equal to f dot v will give me 2 into 2 ka square into 5. So 2 square is 4, 4 into 2, 8, 8 into 5, 40 watt. Okay. Now, this could be your answer. So, Saina, are you getting this? If force is a variable, this is not the only force which is acting here. It could be another force also. So, I am just calculating instantaneous power of this force only. Okay. It might be moving in some other influence of some other forces also. That's why we are getting the velocity like this. Okay. So, just for giving you an example, I have taken a variable force and I have assumed that the velocity will become 5 meter per second at t equal to 2 seconds. Okay. Otherwise, we have to calculate according to this, which you can do also actually, but it will require some kind of integration. That's why I am skipping that part. So, I am directly telling you this, that the instantaneous power of that force at t is equal to 2 seconds will be calculated like this. Is it okay? F equal to 2x is variable, but it is not changing with time. How? No, study empire. Actually, see here, F is equal to 2x. If a force is here, okay, if a force is present, so force will give us acceleration, right? And because of acceleration, there will be change in velocity. And since there is a change in velocity, so that's why velocity is changing. And if there is a velocity, so its displacement or its position will also change, right? So this x is ultimately dependent on time. This is also variable. But here the question says that F is equal to 2x, means the force is not directly dependent on time. It is actually, but we are given here with its variation with displacement. Okay. We can also find the variation of this force with time also. Okay, study empire, are you getting me? If anything, if a parameter is dependent on a parameter which is variable, so if this object or this particle is moving, so its displacement or its position is changing, right? So this is a changing variable or a variable, I can say. And if it is a variable quantity, then force has to change. That's why it is a variable quantity. Yes or no? Okay. So the question was quite simple actually, but we have discussed a lot of things here. Okay. So it's good actually that you are asking some kind of questions. Okay. And it will help you in solving your different kind of doubts. Are you getting this? So the answer of this question is quite simple actually. So P is equal to, or I will write here. So P is equal to F dot V. Instantaneous power is given as 20 watt is equal to, now force into velocity, and this is F V cos of theta. F dot V can be written as Fv cos of theta. Here theta will be 0 actually. Why? Because this is the only force which is acting on it and it is moving in influence of this force. That's why its velocity will be in the direction of velocity only, or the force will be in the direction of velocity. That's why the angle between them will be 0 degree. So it will become 20 is equal to F into V. 20 is equal to, we have to find the value of force, right? So we don't know the value of force, but we know the velocity, that is equal to 10 meter per second. So F will be equal to 2 Newton at that point of time, right? Now if the velocity, initial velocity would have something else, so it will not be equal to 10 meter per second, it could be 2 meter per second at some point of time. That will give me 20 is equal to F into 2. It means the force would be equal to 10 Newton at that point of time. Here the force is variable actually. Here the force is variable, but we have to find the force when its velocity was 20 meter per second. So we can say that the magnitude of force must be equal to 2 Newton. All right. Any problem in this? Let's move to another question. The time period of revolution of a satellite around a planet in an orbit of radius 2r is t. Its period of revolution in an orbit of radius 8r is very easy question. You know the answer directly, right? This is time period of revolution of a satellite around a planet in an orbit of radius 2r. It means if radius is given, it means the orbit is circular, right? So this is, let's say, planet, some planet, and this is the orbit of radius. Initially it is 2r. I am taking it as r. Okay. In general, let's see the formula. What is the formula? Then we will see how can we solve this. So if this planet is revolving with some speed v here, right? So the formula can be given as t square is directly proportional to r cube. This is Kepler's law of time periods or orbits, right? So time period of orbits, that is equal to square of time is proportional to r cube. Can we apply this formula? So yeah, excuse me, can we apply this formula here directly? So yes, t square is directly proportional to r cube. So whatever there is, I can also write that there is some constant. I can assume it as k into r cube. Now I can write that the time period for 2r is t. Okay, so I am writing it as t square is equal to some constant k into 2r whole cube. Now we have to find the time period for radius 8r, right? So I am assuming as t prime, so this will become t prime square divided by k, constant will remain same, yes, and it is 8r the whole cube. Yeah, Lakshman. So t square by t prime square is equal to k. K and k will get cancelled. This can be written as 2r by 8r ka whole cube, right? So this will become 2r by 8r, that is 1 by 4 cube. So this will be t by t prime 1 by 2 square cube, and I have taken a square root of this thing on both the sides, so this will become 3 by 2. Now this 2 and 2 will get cancelled out. This will become 1 by 2 cube, that is equal to 1 by 8. So answer would be t prime is equal to 8 into t. Yes or no? So what will be the new time period? That is equal to 8t. Yes? Okay. Now another question. A spring of a spring constant 100 Newton per meter has 25 Newton force developed in it. The compression in the spring is. So a spring has a spring constant. So let's say this is a spring. Okay. This is a spring and its spring constant is given as 100 Newton per meter. Now a 25 Newton force developed in it, the compression in the spring is. So either this is the, let's say this is the mean length or the natural length of this spring. In natural length, spring exerts no force, neither compressing force or neither this tensile force, alright. But if I extend it here, and it will come from this to this, so let's say this is delta x. Now there will be force, right? There will be force, and the force applied by the spring is against the deformation. So if we are extending it like this, then the spring force will be like this. Okay, so if you are try to like elongate this spring now, then its force will be like this. It will try to regain its natural length. Again, if this is the natural length, and if you press it like this, so its length will become like this. So deformation is this. This spring will apply force in this direction. It will try to again go to its natural length. Okay, the formula is exactly same, but the magnitude of the formula is k into delta x. Or if you want to write it in vector form, then this can be written as minus k x vector or delta x vector. Again the same thing. So I am using this formula here because we already know that the spring always exerts force against its displacement. So the formula would be F is equal to k into delta x or k into x, whatever you can write. Spring constant is 100 Newton per meter and force is 25 Newton. So this is 25 Newton, okay, k is 100 Newton per meter into delta x. All quantities are in SI units, that's why we will get the answer in SI unit, that is equal to 25 by 100. This is meter, right? So this is 1 by 4 meter. But the answer given is in centimeters, okay? So I will multiply this with 100 and our answer would become centimeter, right? So this is 25 centimeter. It means if you have a spring of spring constant 100 Newton per meter, right, and if you compress it by 25 centimeter, the force developed will be 25 Newton. Okay, what happens, what will be the force if I extend it by 25 centimeter? What will be the force? The same spring is there, but I am extending it with 25 centimeter. What would be the answer? The answer would be exactly same, right? 25 Newton. But the direction of force would be opposite. Okay, answer is very simple. This is 25 centimeter. Okay. Manvendra, Saina, Lakshman, study, Abhishek Singh, are you getting this? Very easy question, right? Let's move to another question then. This is another question. An electron in hydrogen atom changes its position from orbit n equal to 4 to the orbit n equal to 2. The wavelength of the emitted radiation is, R is Rydberg's constant. Now, there is an electron in hydrogen atom and its position was n equal to 4. Means it was at higher state sometime and after that it transitioned to n equal to 2. Means it is jumping from higher energy state to lower energy state. Now you tell me, if it is coming from higher energy state to lower energy state, then what will happen? It will absorb energy or it will radiate energy or it will release energy. What will be there? The wavelength of the emitted radiation. Actually the hint is here already, but as you can see, n equal to 4 is a higher energy state and n equal to 2 is a lower energy state. That's why while transitioning from higher to lower energy state, it will emit a photon, right? What happens if it goes from n equal to 2 to n equal to 4? Then it will require energy. Some energy it will require, and that is the only case when it will go from lower energy state to higher energy state. Yes, release, absorbed, release, okay. So different kind of answers I am getting. I hope that from 4 to 2 I am getting the answer that it will be released, and from n equal to 2 to n equal to 4 it will be absorbed, right? Okay, study, already have given the answer. Let's see what would be the answer. So the formula is quite simple, right? 1 by lambda is equal to R 1 by n1 square minus 1 by n2 square. Now what is n1, what is n2? Okay, so this is the higher energy state. So n2 is greater than n1. Yeah, Lakshman. n2 is greater than n1. Okay, so while transitioning from 4 to 2, what I have to write? I have to write that n1 is equal to 2 and n2 is equal to 4. Now let's calculate this. 1 by lambda is equal to R 1 by n1, that is 2, but here is a square, right? So this will become 2 square minus 1 by 4 square. This will be equal to R times 1 by 4 minus 1 by 16. Very easy to calculate now. So this will become 1 by lambda is equal to, R is there, R is already here. I am taking LCM as 16, so this will become 16. Now this is already 16, so this will remain 1, but this is 4, right? So it will become 4 into 4, that is 4 minus 1, right? So 3R by 16. But we have to find the wavelength. This is 1 by lambda, right? So the answer would be lambda is equal to 16 by 3R. 16 by 3R, that is the answer. So the answer is given in form of R already, right? But what is the value of R? If I want to calculate the numerical value of this answer, then, okay, if I want to calculate the numerical value of this option 16 by 3R, then what would be the answer? So R is equal to actually 1.01 into 10 raised to the power minus 7 or 7. It is actually 7, right? 7, and the unit is interesting, per meter. Obviously, right? Lambda is in meter, so R has to be in per meter. Okay, students, so I hope that you are getting this, and this is the end of our 1 hour slot. So I am done with my presentation here. Okay, keep revising and good luck for your next exam. Thank you.